The second PowerPoint in our trigonometry series is called Finding Missing Measurements. Do you remember, and we're going to rewind back to the last PowerPoint, when I asked you to solve for sine, cosine, and tangent using two side lengths. So I gave you this triangle DEF, told you it was a right angle, gave you all of its side lengths, 16, 12, and 20, and I said, what is sine of E? Sine of E is opposite over hypotenuse, so we did 12, the opposite side of E, over 20, the hypotenuse, and it gave us 0.6. And then I said, what does this mean? What is this 0.6? This is the PowerPoint that's going to explain what that 0.6 means. Say I give you a triangle. Here it is. I don't really put the square that says it is right. I'm telling you it's a right triangle. I give you the hypotenuse of 65, and I give you the angle of C, 54 degrees. You could solve for all the sides of this triangle using what I hope you're familiar with, SOHCAHTOA. So we'll do it. I have sine of 54 is opposite over hypotenuse. The opposite side of this 54 is AB, and we know that the hypotenuse is 65, so we would just cross multiply. We get 65 times sine of 54, which is equal to our AB, and we get that AB is equal to 52.59 centimeters. Perfect. We have one side. We are missing the last side, BC. Let's use cosine. Let's use CA. Cosine of 54 is adjacent over the hypotenuse. The adjacent side of BC, the one beside BC, remember, not the hypotenuse, so the side opposite the hypotenuse, so it's BC over 65. We cross multiply, we get 64 times cos of 54 to give us BC equal to approximately 38 centimeters. So there we go. We have all of our sides. Awesome. You know all the sides. Here they are. And you can figure out the missing angle, right? Because you have a 90 degree, you have a 54. So you do 180 minus 90 plus 54, and that gives you 36 degrees. But recall from the last PowerPoint, you were asked to find the sine, cosine, or tangent of a corner. In this case, just to rewind back, what is the sine of A? Here's our triangle again, and remember, sine of A is opposite of our hypotenuse. So locate your A, locate the opposite of A, it's 36. Locate the hypotenuse at 65. So sine of A is 38 over 65, and that gives us 0.58. So sine of A is 0.58. But why? What does this mean? First, find the sine to the power of -1 on your calculator. Usually it's where sine is, but it's the second function. When you find it, plug in that sine of -1 equal to 0.58 and see what you get. When you plug in sine -1 of 0.58, you get 35.45. Let's look where A is. Here's A. What do you notice? 35.45, I got A is 36. That's kind of almost the angle of A. When you find the sine, cosine, or tangent of a corner and you plug it into their power of -1, or also known as their inverse, you can actually find the angle measure of that corner. That's a big rule. I would like to introduce you to 3 new concepts: arcsine, also known as arcsine without the E, or sine of -1, arccosine or arccos, or cos of -1, and arctangent, also known as arctan, and it's seen as tan to the -1. Use these after you've found the sine, cosine, or tangent of a corner to find the angle measure like we did in the last slide. Here's a triangle. You know that it is a right angle. You have all 3 sides. Solve the angles of this triangle. Let's begin with angle F. You could use any trig ratio. I label the sides according to F. So this is the opposite of F, this is the adjacent side of F, and this is the hypotenuse for F. Let's use SAW. Sine of F here is opposite over hypotenuse, so 13 over 16, and that gives us 0.81. If we put in the negative, or the arcsine of it, you get 54 degrees. You could also use cosine. So CA, adjacent over hypotenuse, so the cosine of F is equal to 9, the adjacent, over 16, the hypotenuse, and that gives us 0.56. If we do the arc cos of this, we get 55 degrees. And finally, again, you can use any one of these. If we use TOA, or tan, opposite over adjacent would give us 13 over 9, which is 1.4, and if we do the arctan of 1.4, we get 54 degrees. So right now, just looking at it, we'll recap in a sec. We have sine gives us 54 degrees, cosine gives us 55 degrees, and tan gives us 54 degrees. So here they all are. So now you're saying, well, which one do I pick? Which one is the right one? Well, honestly, it really doesn't matter as long as you're within 3 degrees of the right degrees. Okay, if you picked something like 65, you'd be completely off. So depending on your rounding and depending on lots of things, you might get different answers, but they're all going to be somewhat similar. In our case, let's choose 54 degrees, just because sine and tan have it, but even if you pick 55 degrees again, you're allowed a little bit of leeway in these cases. So now we found angle F. You could use the 180 degree rule to find D, and you would find that it was 36 degrees. That's great. But in respect to this PowerPoint, let's check using the trig ratios, just in case. Here is what the sides are labeled in respect to D. So this is the adjacent side of D, this is the opposite side of D, and this is the hypotenuse of D. Please feel free to do this. It helps you, it helps me, and it will help you when you do your trig ratios in order to find the sides that you need. Using sine, we have that the sine of D is opposite of our hypotenuse, so 9 over 16. That gives us decimal 56. If we do in the arc sine, we get 34 degrees. Keeping in mind that we know that it's 36. We know that it's 36. The next one is cosine, so ca, adjacent over hypotenuse. We'll have the cosine of D is equal to adjacent 13 over hypotenuse 16. That gives us decimal 81. If we do the arc cos, we get 36 degrees. And lastly, if we use tangent, opposite over adjacent, we'll have tan of D is equal to 9 over 13, and that gives us decimal 69. If we put in the arctan of this in our calculators, we'll get 35 degrees. So just to recap, here's our triangle. We have one way of finding D by using the 180 rule. It's 36. We did the arcsine, which gave us 34, arc cosine, which gave us 36, and arctan, which gave us 35. So again, we have all these different answers, but they're kind of like 3 degrees between each other, so not such a big gap, so not that much of a big deal. All of these answers would be acceptable. Just because, let's pick 36, and voila, we have found all the angles of this triangle using only the side lengths. I think that's pretty cool. So putting everything together, I give you this right angle triangle, I give you 2 side lengths, and I tell you to find all the missing measurements. When textbook question or a test question asks you to find all the missing measurements, keep in mind all missing measurements means all the angles and all the side lengths. So solve all of those things. And just for the sake of this PowerPoint, try not to use Pythag. There are many different ways that you can start this or go about this. So I'm going to start it off in 2 different ways. The first way that you could start this is by finding angle Z. Okay, I'm starting with my angles. You could start with using your missing measurements. It doesn't matter how you start this, as long as when you do answer whatever measurement you're looking for, you do it in the right way. So here's angle Z. You are given the opposite of angle Z and the hypotenuse of angle Z. I hope you see this. So because we're given the opposite and the hypotenuse, we could use sine to find the angle Z. Remember, I'm looking for the angle of Z. So sine says opposite over hypotenuse, so 76 over 103 gives us decimal 74. If I do the arc sine of this, I get 48 degrees. Voila, I just found angle Z. Really took me 2 seconds. Very easy. So now we found angle Z. If you wanted to start by finding angle X, you could do the same thing, except notice that with angle X, you're given the adjacent of X and you're given the hypotenuse to X. Adjacent hypotenuse, cosine, use ca. So the cosine of x is adjacent over hypotenuse. In our case, it's 76 over 103, and that's decimal 74. If I do the arc cos, I get that x is 42 degrees. So already in 2 slides, I've gotten both of my angle measures that are missing. Now, I had found angle Z in 2 slides ago. I could use it to find my missing side, my ZY or my YZ. I'm given opposite and hypotenuse. Remember, in respect to Z, I'm given the opposite side and I'm given the hypotenuse. I need the adjacent side. So looking at my SOHCAHTOA, I could use CA or I could use TOA because I need that A. I need that A. Using SAW, it would be useless for me because it won't solve for my A. Using TOA, if I do the tan of this 48 degrees and I say that it's equal to opposite 76 over this unknown adjacent side and I cross multiply, I get that my ZY is approximately 68.43 centimeters. That's using TOA. You could have also used CA because remember we're looking for that A. And if we did, we'd have the cosine is equal to adjacent, and in this case it's our unknown ZY, over our hypotenuse, which is 103 centimeters. And when we cross multiply, we get approximately the same thing as our TOA, 68.92. So let's just settle with 68 centimeters. So using angle Z, we have found our missing side. Or if you had preferred, you could have used angle X for your missing side. We had found that it was 42 degrees. And in terms of angle X, you're given the adjacent over the hypotenuse. You are missing, looking at angle X, the opposite of X. So in the last slide, ZY was our adjacent because of Z, but in this case with our X, it's the opposite side. So looking at our SOHCAHTOA here on top, using CA would be useless because we're looking for that O. So I am going to show you how to find O using SAW and TOA. So starting with TOA, we have that the tan of 42 is equal to opposite over adjacent, so ZY over the adjacent 76. By cross multiplication, we get that ZY is approximately 68.43 centimeters. On the last slide, we know that this is good, this is on the right track. We got this number using angle Z. Had you decided to use SAW with angle X, you would have sine of 42 is equal to opposite over adjacent, so sine of 42 is equal to ZY over this 103, opposite over hypotenuse. So your sine of 42 is equal to ZY over the hypotenuse, and you would get that ZY is approximately, again, 68.92. We're just going to settle with 68, and that's the same thing we got in the last slide, so we know that we're on the right track. So in conclusion, given any one side or any one angle of a right angle triangle, you can always find the missing measurements. And remember the missing measurements, all the angles and all the side lengths, just by knowing SOHCAHTOA, how to use it, and the arc sine, arc cosine, arc tan. Just one more fun fact before I leave you on this. There are certain triangles called a 30, 60, 90 triangle, which basically tells us that the angle in this triangle are 30, 60, and 90 degrees. The rule states that the length of the side that's opposite the 30-degree angle in that triangle is equal to half the length of the hypotenuse. Here's a 30, 60, 90 triangle. So the 30 degrees here, the 90 degrees here, so you can assume that the 60 is here, right? So this is a 30, 60, 90 triangle. AB here is the side opposite 30. And I'm telling you here that the side opposite the 30-degree angle is always equal to half the length of the hypotenuse. So for example, if the hypotenuse is 40 centimeters, the side opposite 30 is half of the hypotenuse 40, so it's 20. So without doing any trig, just by using this rule, you know that because AC, the hypotenuse is 40, the side opposite the 30 degrees is 20. Or if your hypotenuse AC is 10, AB, the side opposite the 30 degrees, is 5 centimeters, etc., 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 etc. So just a cool rule that might help you when you're solving for side lengths. And this concludes our 5.2 chapter on missing measurements. Up next, 5.3 helps you by calculating the area of any triangle.